Okay, so welcome. Now, in this example, we're going to use a limit comparison test to test to see whether this converges or diverges. So what we're going to do is we're going to compare it to this series, n equals 1 to infinity of 1 over the square root of n. Now, notice that this is, what? It's a p-series, right? So this is 1 over n to the 1/2. Okay? So in this case here, we're going to use the comparison test. Okay? Since we know this diverges, right? So divergent p-series, p is less than 1. So now, what we're going to do is we're going to take the limit as n approaches infinity of the ratio of these two. So it's going to be 1 over the square root of n plus 1 divided by the square root of n, or 1 over the square root of n. And so this is going to equal the limit as n approaches infinity of what? This becomes the square root of n over the square root of n plus 1. Well, what's that limit? Well, they have similar, excuse me, right? How do I want to do this? Well, if you divide the top and the bottom by the square root of n, we get the limit, and I've showed you this before, something similar to this, right? So we divide the top and the bottom by the square root of n, and what do we get? We get 1 over 1 plus 1 over the square root of n. Well, this obviously goes to 1, right? So that's going to equal 1, which is not equal to 0, right? Not equal to 0. So that means that what? Since the series of 1 over the square root of n diverges, the series 1 over the square root of n plus 1 diverges by the limit comparison test. That's it.